Alright, so hello everybody. So this should be what you were doing on the asynchronous Wednesday. Okay, so there's nothing to turn in today. It's just watching this lecture and making sure you're taking notes. So again, you don't have to turn in or send me the notes. Just make sure you're putting them in that shared Google folder. Okay. And so today's topic is kind of wrapping up some things that we've been working on and pulling things together. Okay, so the last couple of days, we've seen the shell model. We've talked about how the shell model shows electrons. And so we're actually going to categorize our electrons into different types. Okay? And the reason why is that the arrangement of our electrons in their shells is very predictable based off the periodic table. Okay? So if you were in person or if you came for the picture day, hopefully you now have a physical periodic table to use. Otherwise, you can continue to use the one in Google Classroom. But we're going to see that the arrangement of electrons based on where an element is on the periodic table is very predictable. Okay? And so if we were to draw a shell model, the last shell that we have in our shell model, our outermost electron shell, is known as the valence shell. Okay? So the last final shell is what we call the valence shell. And so any electrons that are in that shell, in that outside shells, are what's known as the valence electrons of an atom. Okay. So again, the valence shell is the outermost electron shell, and any electrons that are located on that shell are known as valence electrons. So any other electrons that we see in an atom are known as core electrons. Okay. So any electron that is not a valence electron is known as a core electron. And so this is an image from a couple weeks ago. So when you did that build a periodic table activity, one of the things we looked at was tick marks, right? And so what you saw was that in each column here, the tick marks are the same for every element, right? So like in this column, they all have 4 tick marks. And so what those tick marks symbolize is actually electrons. Okay? And so those tick marks symbolize our valence electrons. And so what that tells us is that in a column on the periodic table, all our elements in that column have the same number of valence electrons. All right? So if we were to look at, this is more of what we see of the periodic table, right? So if we were to look at that periodic table, we see that, okay, in our group 1A, all right, our first column here, V is for valence and C is for core. And so we see that they all have 1 valence electron. All right. And it goes on, we have like 2 here, 3 here, 4, and so on. So notice that there is an exception up here. Okay, helium only has 2 valence electrons, even though it's in the 8th group. Okay, and everyone else has 8 in it. The reason why is that helium only has 2 protons. Okay. And so since it only has 2 protons, it also only has 2 electrons. But every other one you'll see matches up. Okay. And again, another shortcut that you can see is that the valence electrons actually match the group or column name. Okay. So in 2A, for example, we have 2 valence electrons. In 3A, they all have 3 valence electrons, and so on. All right. So again, there is some patterns with core electrons as well. You can see that as we go across a period, so a period is the row, right? Our core electrons stay the same. Right? So like everything in the second period has 2 core electrons. Everything in the third period has 10 core electrons. Again, you can notice that there is some exceptions down here. If you look at the last column, or the last row here, the last period, our ones over here have 28 core electrons, okay? But then our ones over towards the beginning only have 18. So I know this annoying thing is popping up. But what we see is that our ones towards the right side of the periodic table have 28 core electrons. And again, the reason why is that if you look on a real periodic table, you'll see there's actually 10 elements between calcium and gallium. And so that's why the core electrons jump. But for the most part, you can see that there are some predictable patterns, right? And so if we look, this would be like our shell model representation of all the elements in the second row, okay, so the second period. And then this would be like our sodium shell model, so this would be something in the third row, the third period. And so what we see is that across a horizontal period, across a row, the number of valence electrons increases by 1. So lithium has 1 valence electron, beryllium has 2, boron has 3, and carbon has 4. Again, we can find valence electrons by counting the electrons that are in this outermost ring, this valence shell. So like there's 2 valence electrons here because there's 2 electrons in this outermost shell. Okay. But as we go down a group, okay, so the columns, the vertical columns are also called groups, right? The number of shells increases by 1. Right, so if you were to look at the periodic table, sodium is below lithium. We see that lithium has 2 shells and sodium has 3 shells. Okay? So as we go down a vertical group, the number of shells increases by 1. All right. But what we notice is that even though our shells increase, our valence electrons stay the same. So lithium and sodium are in the same group, the same column. Sodium has 1 more shell, but it still only has 1 valence electron. Okay, so every element that is in the same column is going to have the same number of valence electrons. Okay?